So this is problem 1.7, right, from Artin. Yeah, let us do this. We'll only get more interesting, I think, because we are learning and the problems are also getting harder. So that's a good balance. So basically now we want to, with 3 by, of course, 3 by 3 case. You want to calculate this. So are there any guesses, any?
Will we do this like this into this again, and then we will get something for n times then, like the previous one?
Yeah. So the answer will be in terms of n. So up to that, it is like the previous one, but it won't be exactly like that. The pattern will be slightly different. So yes, we should do the small cases and see the pattern. If you people cannot see it directly, then you have to do it and see, right? I guess that's the only way. So you have to do it and see, then we will see the pattern. And then I will introduce some technique maybe, which I know. So I can tell you that I'll say that first. Let us just do it by hand. Let us get our hands dirty and try to do this and try to see what goes on when you multiply. So what will happen to the first column?
Column?
Yeah, the leftmost column of the output. So now you notice I'm not asking about an element. I'm asking a general thing. What will happen to the first column?
It will be same.
It will be same, right? Yeah, that's what, right? So there's a good answer to it, right? That's why there's a question for it. So it will remain same, okay? And it will always remain same, right? It will never change, right? So that much you know, that's fine. What will happen to the second column in the output? Or you can just calculate and see, okay? You don't have to answer that question directly. What will happen to the second column? You can compute the terms one by one and also see. So you must be getting 210.
Yes.
Right? And what happens to the third column?
3 to 1.
3 to 1, right? Yeah. So how will it grow? Any idea? How is it growing? What will happen in the nth? Let's see if we can jump and directly say about this. You know that this will remain the same. Yeah. What else can you say?
Then it will become n plus 1, and then the next one will become n plus 2.
I don't know. That is. No, will it be
N and 3n, right? N and 3n.
okay? N and 3n. That is So that is the suggestion that Nagesh is making. And maybe this is yeah, this is correct, I think, right? Or yeah, let us see if this is correct. So what will be here in the middle? So this will be 0, right? This will be 0 and this will be 1 and this will be 1. Okay, so we need to understand why that happens as well. But let us assume that part, okay, that the diagonals will remain 1 and the lower of the lower diagonals will be 0. That we can show in general. What will be this one? We are just making guesses. So if there is something that will it remain n?
Yes, if that is n, it should also be n.
Okay. Think if this is correct or the other one that Shirin was saying that is correct. Think. So see, this is not correct, right? Because if you have n, so here n was 2, but here we don't have 3 times 2. So this is certainly not correct, right? So maybe it is 3 times n. I mean, this is 3, so this cannot be 3n, right? That is not correct. Maybe 3 times n minus 1. I don't know. Yeah, but this way what will happen? This way we cannot really understand, right? We cannot move forward this way. So let's not. So yeah. So what should we do? Are you confident about this n? Are we having confidence about this n? So let us see that this was a question mark. Okay. Now you know what we are multiply by this. So will this n become n plus 1? Just check in the output which entry you want to calculate, and for that what you have to do. It does, right? It does become n plus 1.
Yes.
Yeah, and you can just multiply it, right? So this one needs you to multiply this by this and so on. And so this is, so what have we learned? We learned just a small technique that if you make a guess, you can check if it is correct by small cases, but you can truly check if it is correct if you can just, in general show that it grows in the same, like mathematical induction basically, without writing it like that. If it is n, then the next one should be n plus 1, right? And then that is correct. And so that seems correct. Is to say, unfortunately, it doesn't depend on this question mark. Okay, so that is okay. Now, what should that question mark be? How do we understand that? How would we do it in a down-to-earth way, right? Without knowing a lot of maths, without knowing some other techniques and so on. Well, if I was, let's say, if I did not know any matrix theory, how would I do? I would just continue to multiply one more time. What else will I do? And then I'll try to understand what this thing is. So what is that? What will this become?
6.
It will become 6. So most importantly, yeah, it is becoming 6. But what is it? It is basically taking these 3 things and adding them. Shirin, is that making sense? At each stage, that question mark may, that thing is getting added. So if it is 6, then what will it be in the next stage? Right? Again, we can keep making guesses and you can find it, but let us do, okay, so yeah, okay, let's just say that we make more guesses. Okay, so this will be 6. Okay, so let's just go by guessing way, or sort of guessing and writing patterns. So initially it was 1, then it became 3, then it became 6. What will be next after that? So this will be 6 and this will be 3 and this will be 1.
10.
10. Any pattern? I don't do mathematics like this. I used to also do like this. Huh?
15.
15. Okay. So now you can understand what will it be in the nth term. It is the nth triangular number. Or I mean, basically it is n into n plus 1 by 2. Because you see that each stage it's like, adding 4, then adding 5. So it is this. Okay. Shirin, is this pattern okay? I am trying to do this in the most down to earth way. So we will,
Yes, sir.
right? Because how else will I know what it is, right? How else will I know, right? If I only know matrix multiplication and I'm good at calculation, this is what I will do. But then, as I said, you pass it through the next test. That is whether it grows in the same way. You assume it and see the next one, and you can see for yourself that it does happen the way you would think it does, right? Or wait, so yeah, this is fine. Yes, so now you see in the next stage, this one will become, what will it become? It will become 1 plus n times n plus. It is exactly what you want, absolutely what you want, right? Adding n plus 1 to this thing, and then that will make it, just n plus 1 to the sum of the nth natural numbers means sum of the n plus 1 natural numbers, right? First n plus 1 natural numbers, and that's it, boom. So it correct. Pattern grows in the same way. This is not this cannot be covered by, I mean, this, okay, can be, but this is not a standard theorem. This is something which you have to work out. Either you do it like this, or I will say something which will be same, but okay. All right. So the other way, if I want to make this thing automatic, then how would I do? That diagonal thing remaining 1, the lower thing remaining 0, those are important things in matrix multiplication, important results of, important consequences of the matrix multiplication, which we should just look at, but we will see that. But this one is sort of a little ad hoc. Okay, so you see, I will say that, okay, let us say that the nth term is an. Now a little bit of, computer science sort of thinking, recurrence thinking. Okay, which is not like a pure math kind of thinking. It's a little bit whatever. It's a recurrence thinking. This is let's say that this, sorry, yeah. So let's say this is an, and some foresight, you people are able to tell me that this is an, though I suppose you don't have a proof of that. But if you understand, I mean, they are same. They are meeting the same fate at every stage. It's going in the same way. So this is Bn. Now I want to set up a recurrence, right? So now obviously the n plus 1th, this is this. These are the some techniques, okay, which people with that background will have it automatically. If you don't have it, then you learn it now, right? So yeah. This is the thing. And now anyone can tell me what should the recurrence be? What should the connection be between an and an minus 1? So obviously we have already done it. It's just matrix multiplication. An plus 1 is what? It is this times this, right? And what is that? Fortunately, that is not very difficult. It is just 1 plus an plus bn times 0. So we don't write it. Okay. And again, what is bn plus 1? Similarly, like the recurrence kind of thing. ये कैसे आएगा? How will this come? This one will come, you know how it will come, this times this. And so that is, so what is that? Right, it will be this, right? And that's it. And you know, you better know what an plus an plus 1 is an. Everybody knows that an, it means that an is equal to n. Obviously, because a1 is 1. So you that, then this is n. That's it. So we have a clear way. What this helps us is that even if there was a more complicated pattern which you could not see, or if you don't want to multiply 3 times and those kind of things, even some more complicated patterns can be captured by recurrence. Right? Pattern may be complicated, but the recurrence may be telling the true story. Right? The differential equation may be telling the true story of the function. This is basically that. So that's it. So you know that bn plus 1 is n plus 1 times bn, and then you can know find bn plus 1, right? So it is bn is n plus that, and so it's n plus 1 plus n minus 1. Yeah. Okay, so this is just it's nothing. Yeah, it is just getting better at matrix multiplication, and not in the sense of getting faster in terms of speed, but in terms of this speed of applying the right techniques. Okay, so yeah, I mean, even I don't understand many things in this. I don't know. I mean, I can write a recurrence, but I don't know what will happen in the end if it was a arbitrary m by m matrix. And yeah, in this case, we found the answer. In general, also there is something very nice, but I will probably not discuss this now. Like if you have this, right, then that part will be same, but yeah. Yeah, I'll think that's for my own thing to think. You can also think maybe at least try the 4x4 case. So maybe you can, I think, I think this should be a homework, right? This is a nice 4x4 case is fine, right? Please tell the 4x4 case. Okay. I mean, there is some insights. It's growing in the same way. I mean, it's a nice thing you see, and this will be actually the next one on block matrices. Will actually help you to understand this better. You will see, and then you can appreciate why block matrices are so nice things, not just So when you multiply this for n, now let me say this thing, and you will probably agree with me that this one is fine. We will be fine with that. Then you will see that this will remain n. Right? Is that
Yes.
right? You can see that, you can check that, you can prove that, but you will also see that this goes back to like one of the earlier questions which we did, because this multiplication is happening in this world. And there we know it is, that's how it is. That was one of the earlier questions, right? For 2x2 case, that's multiplication is like addition. We saw that. But the later ones become more complicated. Well, and since we have done it, I can tell you that I hope this is Is this correct so far?
Yes, that's the same, right?
That is the same. Yeah. Why is it the previous? It would why? Yeah. If it is the previous, then it is correct. But why is it the previous?
Again, the multiplication is happening only between because the three. Yeah.
No, but that but here there is some. One can go wrong, but one has to explain carefully. There it was like different. How do I say? We will come to that when we do block matrices. The sizes are not compatible, but you are maybe still correct. It is still correct, I think, in the sense that, well, I'm just saying too many words. It's very simple, right? It is just that when you multiply, when you want to find this entry, right, you can see that uh, uh, this row goes with this column, right? And you can see that even though this one is there in this row, this guy is a 0. So never gets the opportunity to interact with the 4 by 4 boundary, the fourth row and fourth column. Yeah, truly the multiplication never interacts with the fourth column or fourth row. Yeah, it does sort of formally starts, this one is there, even when you compute, yeah, it is there, but then it doesn't interact with this. So I suppose that is correct. But then computing these, and this will also be, I think, something, and then computing this probably is a little more interesting. And this will be n or not. Think all this is there, right? You have to just check it out. I mean, okay, patterns. So these are very, they play a big role. No? Also, but also small roles for your exam, huh? Yeah.
Yes, that is n.
That is n. Why is that n? Any nice explanation?
Again, the same reason the last one is never getting to interact with the 0 of the third column. Right. The fourth.
Fourth row, no, third row and fourth
Third
column.
row.
Yes, yeah. And right. And this is also from, yeah, it's happening in this world, right? That much is there. And then you can kind of, here you can kind of prove some very interesting things that, no matter how large the matrix is, you may not understand the terms, but you would know that on the diagonal, super diagonal, all same, super diagonal, all same, super diagonal, all same, right? That kind of thing is there, and those matrices have a lot of meaning in combinatorics, lot of everywhere, commutative, lot of things. We'll not be able to talk about that now, but yeah. So we will close the class today. We will not move forward, but I will let you with one more insight which can help you to do these questions better. Okay, and this is the slight theoretical part, a little bit. So we are basically getting better at these things which are important for us to get better at. So let me just tell you till where I plan to go. Maybe I can share the screen before. I'll tell this, then I'll tell the sort of interesting way to see matrix multiplication. We will do these things. This is fine. So I only want to do till what is necessary, So till 1.115 we will certainly do. There is no question about that. Okay. And meanwhile, we will learn what we need to learn for that. Yeah, we should do these a little bit. Yeah, I think we have to do these things. It does take a little bit time, but we should do. Maybe I can skip a few questions in between if I see that. Yeah, but okay. For section 5, you don't need to do. I don't think that is some interaction with some other things that I don't think is needed. So you can skip, and other those things is not needed. I suppose. Miscellaneous certainly not. Yeah. Section 4 tak, if you do, then you can be, yeah, you can relax about matrices. Okay, and obviously the corresponding exam papers we will try to solve. We will see, but wherever we can find matrix questions at a stage where it is just matrices are not interacting with too many other concepts, we will do them. Okay, let me then just give you a matrix multiplication basically, but we want to understand them in terms of vectors. Okay. In terms of vectors. So, for example, you look at, yeah, so maybe I'll just say it like formally. I will not try to give intuition at this moment because, yeah, there has to be some balance that I have to keep. You understand what this means, right? I'm not writing the terms, I'm just writing the rows. Now, here I will write a few terms. Okay. Let me ask you, if these three were 0, then what can you say about the third row of the product? What can you say about, I'm only interested in this. I'm not interested in the answer, total answer, about the last row.
0.
0. By your matrix multiplication rule, you can say it is 0. So it will be 0, right? So basically it sort of builds on that. And here is what happens. Let's say that it is this. Then what will the first row be? Well, the first row, now you may find this a little strange symbol, but just have a look. First row will be this. What am I doing there? I am multiplying, I'm taking this, I'm treating this row as a vector, right, as a triple of numbers, and I'm multiplying it with A11. So this is a triple of numbers. Similarly, this triple of numbers, I'm adding them. Right. So I am thinking of this row as a vector and not as three numbers. The point is that if you think of it as three numbers, then you may lose the meaning of the question, where the question comes from, where the question is asking itself to be solved. And if you don't get there, then the solution may become complicated. It can become very, very complicated also than what is necessary, and so practically not solvable in the exam. So now what is this? Let me just give an example. The proof is just, there's nothing to prove in that. But yeah, so let me now write this as numbers and you can just see. Okay. But finally, it's a very nice thing. It's even easier than the usual matrix multiplication rule, which has its own benefits. Okay, it has its, as I said, different sources, different interpretations will be needed to get to the correct way to do the question. It's a technical subject in that sense. If you don't find the correct way to argue, you can get into circles. Okay. So this is, and now what am I saying? Well, all I'm saying is that you treat this as vector. Yeah, so usually we put commas, if you will. And similarly, you put commas here, and then this. I'm not writing. You can write it, right? C21, C22, C23, and similarly this. And you add this, and you get something. What do you get? You also know, right? So you get A11, C11. You add the components, right? Just how you add things, add vectors. Obviously, if I expand it like this, it again goes back to the same thing. But there is a benefit in interpreting it. Yeah, and then you can write this. Say this is the first term, right? And this is the first this thing. Then second this thing, and third this thing. And then when you want to write it as matrices in terms of, then you remove this these commas. Right, so this becomes the first term, 1,1 entry. This becomes the 1,2 entry. This becomes the 1,3. Okay, and obviously this is what you get when you do the usual multiplication also. So that's not proving it. So is it understandable what I'm doing, right? I am taking this row and multiplying it with this weight. I'm taking this row, multiplying it with this weight. this row, multiplying it with this weight, adding the rows as vectors. And the resulting vector is my first row. So I'm doing it on the level of rows. You're not going into the elements exactly. And this can be very, very useful. Okay. So coming back to the elegant formulation, this is the elegant formulation. Okay. This can help you to see a lot of things. It's a combination of, so the first output in the first row only depends on this first row. And obviously it depends on all these rows, but it depends on the first row, and there are the combinations. And similarly for second row and third row of the output. And similarly for columns, but we can talk about it next time. It's better to absorb this slightly and small. And then so yeah, as I'll just say that this week also we will continue to do this. Okay. And we will solve as many as we can. Maybe next time also we can try to solve 5-6 questions. And yeah. Okay. And then we'll see. So then we'll meet, yeah, for this particular class, we'll meet on Saturday is the time, or Sunday, Saturday 9 p.m. We'll meet on Saturday 9 p.m. Okay. All right, so then I'll stop.
Yes.
Yeah, I think we are going to shoot over time a lot. So yeah, okay, take care then. Okay, bye. Thank you.